camera over a little bit. Now my cutoff is. All right, so what do you see? What? Ethyl, ethanoate. Both sides are eth. One side is ethanoate, the other side is ethyl. So it's ethyl, ethanoate. Ethyl, ethanoate. Methyl ethanoate. This part's the ethanoate, and right here is the methyl. Methyl ethanoate. You got that? Those aren't too bad, just a little tricky. You have to pick the fragment correctly. Amines are pretty straightforward. All right, I've said before that nitrogen there's the Lewis structure for nitrogen. So how many bonds does it make? Yes. Everybody said 3. I was just being difficult. So to make 3 bonds, it's an amine. If 2 of these are H's and one of these is some kind of carbon chain, I'll just make it really short. That's an amine. That's another amine. There's another amine. So you can have H's or some hydrocarbon fragment on any of these spots. And when you name it, it's actually very straightforward. This first one, you've got a methyl here, a methyl here, a methyl here, trimethyl amine. That's trimethyl amine. Makes sense? This one only has 1 methyl on it, and these 2 are hydrogens. So you just kind of ignore these hydrogens. They're kind of a null case. So this is just methyl amine. Just 1 methyl there, and you just kind of ignore the 2 hydrogens. This has 2 methyls, so it's dimethyl amine. Make sense? Dimethyl amine. And again, that space shouldn't be there. When you see these written in the book, it's all stuck together. So dimethylamine is technically just 1 long word. I split them up like that just so you can visualize how the naming works. What do you think that is? You have a fragment that you would call propyl, and you have a fragment that you would call methyl. And which one goes first in the naming? Alphabetically, you go methyl propyl. Yeah, it's M and O P. Methyl propyl amine. Makes sense? You've got a propyl fragment and a methyl fragment. M comes before P in the alphabet, so it's methyl propyl. I have to think too. I have to start going A, B, C, D, E. Methyl propyl amine. This one is just propyl amine. The only thing there is 1 propyl. In this case, we have what we would call, so we would say dimethyl because there's 2 methyls. also say propyl because of the propyl. And then we want to alphabetize, but we ignore this part, this numerical prefix. We're still going by the M and P. So M, NOP, so it's dimethyl propyl amine. Dimethyl propyl. Makes sense. There's two methyls there, so we say di.
So what if it was 2-dimethyl and ethyl? Would the ethyl go with the dimethyl?
Yeah, if you had, erase this. If it looked just like that, except for that propyl was an ethyl. So there's our dimethyl. If this were ethyl, this is yep, that single ethyl comes first. Alphabetical order. This is just ethyl amine. 2 carbons. And again, that space shouldn't be there. You would typically hear this pronounced ethylamine or ethylamine, something like that. I emphasize the name just by saying ethylamine. Different pronunciations are really kind of optional. Chemists know what you're saying. You say it. So we have diethyl and methyl. Ethyl comes before methyl alphabetically. So diethyl, methyl, amine. Makes sense? Diethyl, methyl. Alphabetical order, ignoring the numerical prefix, di. Okay, amines. That's amines. Okay, let's try this. So now we're down to the graded one here. The graded ones have this little wiggle next to them. So this is all those together. So, what category is that? It's an ester. So what's the name of it? This part goes together. This is the O8, propanoate. And you've got this, which is ethyl. So this is ethyl propanoate.
So does the anoate go on whichever side of the break it's on? So
Yeah.
if it were on the other side, would it go on the ethyl?
Well, what do you mean by the other
Like,
side?
If the oxygen with double bond is on the carbon on the left side,
Here?
right?
Okay, let's draw both of these. That one. These two oxygens go together on this fragment. So just visually think about breaking it here. This is the O8. There's 3 of them, so it's propane, but not the E, propanoate. On this side, that's ethyl propanoate. All right, now drawing it the other way, if I did this, you know, again, these two oxygens go together on the fragment, so we're thinking about breaking it there. So now this is not ethane, it's ethanoate, and this part is propyl. So it's there's the ethanoate, and there's the propyl.
So it's the side that the double bond oxygen isn't attached to that comes first?
Yeah, you can see
Okay.
that. I'm just telling you to break it into a fragment. Break it here at this oxygen, and these two oxygens are together. And then if you could visualize that, this is the part that's the O8, and it always goes last. And this is the part where you just add the YL, and it always goes first. Which direction it's going forward doesn't matter. That's propyl ethanoate. That is also propyl ethanoate. Because now we would break this fragment off and go, this is the O8, there's two of them, so it's ethanoate. And then over here, we've got propyl. That's propyl ethanoate, and that's propyl. They are the exact same molecule. I'll pop this one off the board and spin it around. It looks like this. Propyl. Here's a carboxylic acid. 5 carbons. This one is oic acid. So 1, 2, 3, 4, 5, pentanoic acid. And here we have a what? Which one is this? Alcoholic ketone. Not an alcohol. Aldehyde. And this is the one, aldehyde is always on the end, just like a carboxylic acid is always on the end. So you don't have to number anything here. 1, 2, 3, 4, 5. So if we have 5 carbons, that's just pentane right there. Now I've turned it into an aldehyde. And to snap the E off, it's Al. That's pentanal. Remember that one? That's a review from the other day. So what is this? It's aldehyde, alcohol, ketone. So this one you do have to number because that carboxyl, this is the carboxyl group, it's not always on the end. In fact, if it's a ketone, it's never on the end. 1, 2, 3, 4, 5, 6, 7. Is that 7? 6. Is it 7 carbons? 1, 2, 3, 4, 5, 6, 7. Got it all like this. That should be there. 1, 2, 3, 4, 5, 6, 7. Okay, it's not heptane. That's heptane, all hydrocarbon. But if I do this, now it's not heptane, it's heptanone. We did that with this one the other day. It's heptanone, but you need a number here. We won't count from this side, we'll count from this side to keep the number the lowest. That's 2 heptanone. It's not 1, 2, 3, 4, 5, 6. It is not 6 heptanone. No, that's wrong. It's 100% wrong. It's 2 heptanone. Because instead of a 6, we can use a lower number by counting from that side. So 2 heptanone. Just as a review, that's 3 heptanone. And just as a reminder, I could draw this going up or down. It doesn't change it. That's 3 heptanones. It's just the writer's choice whether you point it up or down. 2 heptanone. Here's an ether. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. So we've got methyl, let's say 6, is that what I said? So it's something ether. Alphabetically, H comes first, so it's exhale into. This is the one that will be graded. And these are coming from the question. So this is an amine. You've got a methyl and you've got an ethyl. So it is ethyl, methyl, amine. Alphabetical. Methyl, methyl. So each one of these comes from those different question pools. So if you go through this and you get them all right, good. But just for the repetition and practice, know that they're not answer 1. Oh, if you guys want to report to me a mistake, don't use, like this is question 2. See that? Question 2. But if you're like, question 2 was wrong, and you explain to me what's wrong and I want to fix it, what I need you to give me is question 2. Question 2. This is the number I need because I have that linked in the database. Because that's not always going to be question 2. You know what I mean? So that number that's in parentheses is what I need to fix any mistakes. You'll find 1 or 2. I've been knocking them out. 3, 4, 5, 2, 3. Exit. All right, so that one's graded. It just mixes it up, so you have to remember them as you go. All right. So branched alcohols, branched aldehyde, branched carboxylic acids, and branched ketones. All right. Those are all not graded, but naming all of these shows up in this one as graded. So let's go through these. So what do I mean by a branched alcohol? It's an alcohol. Here's your straight chain portion. Here's the alcohol, hydroxyl. But you have this branch going on there. It's a short branch. I've got it written as CH3. I think I mentioned this. We'll talk more about the different ways you can represent structures. This is not deep, so don't let it throw you off. that's what I've got there. This CH3, I could draw it like this. The 3 H's, I could do it like I've been doing it. Means the same thing. That's called condensed. It's just a condensed formula. But let me leave it as CH3 just because that one's CH3. So we have a methyl here. We have the OH here. Let me do this. If it weren't branched, that's propane. If I put an OH here, I'm going to snap off the E and say OL. Propanol. That OH could be on the central carbon or it can be on the end carbon. So we need a number here. That's 1 propanol. If it were here, that would be 2 propanol. Either way you count from, it's on the second carbon. If the OH were here, we're actually back to 1 propanol. It won't be 3 propanol because we can number the other way and make it 1 propanol. And again, if I snap this off the board and spun it around, then it'll be obvious to you that it's the same molecule, so it needs to have the same name, 1 propanol. Oh, and by the way, that's 1 propanol. These are all equivalent positions, just like these two are equivalent positions. I could also draw 1 propanol like that. Since it's the oxygen connected to the carbon, it's sort of got the, it's written as HO instead of OH, but that's just because this is where they connect. Chemists like to do that. And similarly, I could put OH there, OH there, OH there, and they would all be 1 propanol. Go back to here. So that's 1 propanol. Now, if I have a methyl here, methyl dash 1 dash propanol, but I need one more thing. It's actually superfluous, the 2, but I'll get to where equivalent structures and things. I may or may not have put the 2 here on this one. Probably should go ahead and explain it. No, I've got the 2 here, so 2 methyl, 1 propanol. It's 2 methyl. Here's another branched alcohol. So this will be 2 propanol, and it's 2 methyl, 2 propanol. Can you see that?
Why is that 2?
Carbon 1, carbon 2, carbon 3. The methyl is on carbon 2. It's 2. These numbers always refer to the position on the main chain. But there is kind of a twist here on what's equivalent and what's not, but I'll come back around to that. Keep it simple for now.
What was the name of this one right here?
That one is 2 methyl, 2 propanol. Does it make sense? Both the hydroxyl and the methyl branch are on carbon number 2, so they both get number 2. 2 methyl, 2 propanol. Whatever this odd little suffix is, whatever we're naming, whether it's oleic acid, whether it's a ketone or whatever, this number right here in front of this part is referring to that. So yeah, this is 2 methyl, 1 propanol. So the OL, the alcohol, the hydroxyl, that's what this number right in front of this part refers to. So that very last number is in reference to whatever this is referencing. This is referencing an alcohol, and that OH is on carbon number 1. So yeah, not graded. The whole database is here. So this is just for a drill. Okay, similarly, when we number these, in order to keep the number the lowest, once we decide which direction we're going to number it, we stick with that same numbering. Here, let me show you what we redraw this. In some sense, all of this naming works best if you start with what you need on the right and work to the left. See, so there's a methyl there. Got the OH up here. 1, 2, 3, 4. If that were an H, not a CH3, and if that were an H, not an OH, that would be propane. In some sense, this is the best way to start. Start with that base name. Since it's an alcohol, we remove the E. So now we're referring to this as an alcohol. So this number that we're going to put here, we're going to keep it the lowest in reference to this, not in reference to this. Actually, it's going to be 2 either way, but the next example will make this more obvious. So this is going to be 1 propanol. And we have methyl here. But we're not going to call that 2-methyl. We've already chosen how we're going to number this. Once you decide how you're going to number it, it stays that way. This is necessarily carbon 1 because of this. We're naming it based on this, where this is. We're naming it as an alcohol. And we've already called that carbon 1, and that's it. That's carbon 1 now. So this is carbon 2, carbon 3, carbon 4. So this is 3-methyl, not 2-methyl. We can't count from one side for one number, and then count from the other side for this number. Once you decide which direction you're counting from, that's it.
For the alcohol, since there's 4 carbons, would that be butanol instead of?
Yes, thank you. Butane. Yes, it is butanol. 4 carbons. My bad. Confuse you. Speak up, let me see mistakes.
Would it be accurate to say 2-methyl?
That kind of works, but it's 100% wrong. Because you want to keep these numbers just the lowest you can get. So yeah, there is logic in what you just said. The problem is there's another way to do it to make these numbers lower. 2-methyl 4. This is 100%. Even though there is logic, these numbers are bigger than they have to be to make them smaller. It does work out that if you take all the numbers in a name and add them together, and you take all the numbers in this alternate way and add them together, you can say that one single number, whichever one's smaller, that's the correct. It does work out. But I always just point to them and say you can see that these are bigger numbers than these overall. These add up to 6. These add up to 4. 3 plus 1 is 4. 2 plus 4 is 6. So this is correct because you're using smaller numbers overall. So branched alcohols. So let's build backwards here. If there wasn't an OH, and if there wasn't a CH3 branch, what would we call this? It is 5, right? Okay. So if this were an H and if this were an H, we would call this pentane. It has an OH on there, so our convention is to go. And since we're referring to this OH now in that little suffix, UL, we're going to number from here. This is necessarily carbon 1. that numbering now. What number is this? 3. That is 3-methyl 1-pentanol. This makes this the lowest number that you can make it. And then that's how it's going to be numbered for the rest of any substituents that are there. That little suffix. Whatever this little suffix is referring to, you make sure you make this the lowest number you can make it. And then that's it. Everything else is numbered that way. So the base name here is pent. So it's pentanol. To keep that OH the lowest number, we're going to use 2. So it's 2-pentanol. If we counted from the other side, we could make it 4-pentanol, but that's wrong, 100% wrong. So 2-pentanol, so it's 3-methyl 2-pentanol. Make sense? So throwing in the branches gives you that bit of a twist. Branched aldehydes.